So we are going to start with the chapter called polynomial. Actually, we had been studying polynomials from class, I think, 7 only. Now, gradually, we are going to get polynomial in broader sense. So first of all, one thing you should know, polynomial means, we'll get into the correct definition, but first you try to understand this. Polynomial means containing more than one term. Containing more than one term, right? So now, actually, from this concept, we had already got these things in our lower classes. Monomial means containing only one term. Then binomial. Binomial means any expression containing two terms. Trinomial, containing three terms. Then we do not have any fixed name for this containing four terms, five terms, six terms, etc. But from binomial onwards only we call them polynomial, right? But polynomial has a different meaning. These are expressions, algebraic expressions with two terms, three terms, four terms. Polynomial is also an algebraic expression with a specific pattern. Now we are going to write that pattern. So what is that pattern? Any expression of the form, any expression of the form a n x to the power n, a n minus 1 x to the power n minus 1, a n minus 2 x to the power n minus 2, and go on like this. A2 x square, a1 x to the power 1, a naught, where these ai's I have written. Ai's means a1, a naught, a n sub, right? These are रियल नंबर्स, कोई भी रियल नंबर्स हो सकता है. n इज ए होल नंबर. होल नंबर का मतलब है n का मिनिमम वैल्यू 0 होगा, अदरवाइज 1 2 3 4. होल नंबर इज कॉल्ड ए पॉलिनोमियल. दिस इज द फॉर्मल डेफिनेशन. इसमें एक पॉइंट स्किप हो गया, इसी के पीछे लगा देता हूं. ए एन नॉट इक्वल टू 0, जो सबसे बड़ा पावर है इसका जोड़ीदार, कोएफिशिएंट बोलते हैं हम लोग, वी कॉल देम कोएफिशिएंट्स. सो दिस कोएफिशिएंट्स में से हाईएस्ट पावर का कोएफिशिएंट को 0 नहीं होना चाहिए. दैट शुड नॉट बी 0. सो हियर आई एम राइटिंग दिस a n minus 1 etc. up to a naught are called coefficients. And the highest power coefficient should not be 0, because this highest power is known as the degree of the polynomial. Degree of the polynomial. It is known as the degree of the polynomial. Please note it down, and once you finish it, raise your hands. Okay, thank you so much. Now we are going for the example of polynomials. I'll write the examples here only so that we can identify. So my examples are like this. Say I write एक अच्छा इसमें एक बात बोल सकते हैं polynomial in x whatever variable I have used because polynomial can be having more than one variable also but here we are studying polynomial with one variable so you can specify the variable. Suppose I have written this, so this is a polynomial and the highest power associated here is 5, so degree of the polynomial is 5, we call that degree, so degree of this polynomial is 5. Now you see there is an absurd thing we noticed. I have to write a degree of empty bracket. So that means what? We have a name provision for polynomial. So we use some letters to use. I can write fx, small fx. You may write px, someone may write qx, anything, right? Any letter you can use. But of course, you should not say that sir x I want to write or y. Do not write like this. It doesn't look nice. Otherwise, other letters you can use. But now you may be asking here, sir, here the powers are consecutive, it is reducing, but here there is a drop. No problem, that can be. Why? Because I can write them in the given format. That is 1 into x to the power 5. Then as power 4 is not there, I can write 0 into x to the power 4. Then 0 into x cube. Then 3 into x square. And then minus 1 into x and then plus 1. So now easily you can identify that I have written all the powers and accordingly I can say that this is the value of a5, this is the value of a4, this is the value of a3, this is the value of a2, this is the value of a1 and this is a0. So I can express it like this. Sometimes missing power may be there, that is not an issue, right? So this is one of the example we have taken. One more example we'll take here. Sorry. So one more example we'll be taking here. Say this time I would like to name the polynomial as px and I'm writing this as x to the power 2 or x square minus twice x plus x to the power 100 and x to the power 99. Now what happens here? Highest power I did not write at the beginning. You see the particular polynomial here. Highest power term is here. Second highest is here. Then like jumbled way I have written. So whenever you write it in the jumbled way, it is not that you cannot, you write. But whenever you write, it is always suggested that you write it in the standard form. So standard form means you have to write the highest powers first and you have to write the whole expression in the decreasing order sequence. This is the standard form. So whenever somebody tells you that what is the standard form of the polynomial, you should write that it should be in the decreasing order of its power of the variable. That's it, right? And degree of this polynomial px is 100. Many a time students commit a mistake, they consider only the first term. No, not necessary. If you write the polynomial in a jumbled way, it is not necessary that you get the first term's power as a degree. This is one of the very important thing. Is it clear to you?
Yes, sir.
Okay. Next, one more example I'll take. This time I'm not saying that a polynomial I'm going to take. I'm going to take an example, but this time I'm going to take an example which is not a polynomial. Sometimes we may be making you confused that check whether it is a polynomial or not. If I write it like this, that 3x square minus 4 root over x plus 2, is this a polynomial? So answer is no, it is not a polynomial. The reason is this. The reason is this root over x. Because root over x means this ultimately will be x to the power half, because all of you can remember from your lower classes that root over x means power half, and definition does not allow us power half because it is told n is a whole number. If n is a whole number, subsequently these numbers are to be also whole numbers. So we cannot get this as a polynomial. Similarly, to confuse you, I can do the same thing here like this also. 3x squared. See, only a small difference I'll do. Root over 3x plus 2. Is it a polynomial? Yes, it is a polynomial. This time root over is there, but root over is not with variable. तो वेरिएबल के ऊपर अगर रूट ओवर नहीं होता है तो मुझे लेना देना नहीं है. That's all. So ये polynomial होगा. Similarly, if I give you a quick example, is x plus 1 by x a polynomial? नहीं भाई, ये polynomial नहीं है, क्योंकि पहला वाले में तो पावर 1 है, सेकेंड वाले में क्या होगा, -1 पावर आएगा अगर ऊपर लेके आते तो. -1 is not a whole number, so it is also not a polynomial. So this is the very important part you have to always keep in mind, right? So you check it, and please, once you finish, give me the idea. I'll proceed for the next point. Okay. Now we are going for the classification. Classification depending on the degree of the polynomial. Classification on the degree, on the basis of degree. So if degree of a polynomial px is 1, that means maximum power is 1, it is called linear polynomial. Linear polynomial. Example is what? Say x plus 1, the degree is 1. Maybe variable y, then y plus 3, y minus 4, anything, right? Maybe half of x plus 1, right? So, etc. So, in general, a linear polynomial form will be ax plus b, where the coefficient a should not be 0. So, this is the general form of the linear polynomial. It may be happening that degree of the polynomial is 2. So this is called quadratic polynomial. These names are to be written. Quadratic polynomial. Quadratic polynomial example I will not write. I will write the general form. Any quadratic polynomial will be of this form, where a is not 0. This is the quadratic polynomial. If degree of px is 3, this kind of polynomial is called cubic polynomial. The general form of cubic polynomial is ax cube plus bx square plus cx plus d, where a is not 0. Highest power should not be 0. That is the indication every time we are doing. Okay, fine. Then degree of px, if it is equal to 4, we call it biquadratic polynomial. Biquadratic polynomial. Why quadratic means degree 4. The lesser all other degrees will be here. So likewise, here also a will not be equal to 0. And then if we get another polynomial of degree 5, we do not have any fixed name like this, linear, quadratic, biquadratic, etc. So that polynomial will simply say it is a polynomial of degree 5. That's all. No else, nothing else. But out of this, I have actually removed so far one very, very important polynomial. One very important polynomial I have missed. That is a polynomial with degree 0. If there is a polynomial whose degree is 0, what will happen? If degree of a polynomial px is 0, then it is called constant polynomial. That means every number can be considered as a constant polynomial. That means if I say 3 is a polynomial, yes, 3 is a polynomial because 3 can be written as 3 into x to the power 0. So power is 0. So this is the degree of the polynomial. So every number, say somebody told you 3 by 2, yes, this is a polynomial. If somebody says root 3, yes, this is also polynomial. I am using more of the time x. You can use other variable as well, right? Till here it is clear.
Yes, sir.
But there is a question now. There is a very important question. The question is that, the bigger question is that, 0 is also a number. 0 is also a number, right? So 0 is also a polynomial. 0 is also a polynomial. So in this case, what is the degree? What is the degree? This is a big question, right? Do you remember what is the degree of a 0 polynomial? A question to you. If you can tell me the answer. Any idea?
No.
No idea. So, okay, no problem. This particular polynomial is known as zero polynomial, zero, right? Zero polynomial. This is unique of its kind. Unique मतलब इसका जैसा बस एक ही है. And the thing is that its degree is not defined. Please be very, very precise. जीरो पॉलिनोमियल का डिग्री डिफाइंड नहीं होता है. जीरो पॉलिनोमियल का डिग्री डिफाइंड नहीं होता है. बी वेरी वेरी स्पेसिफिक. जीरो पॉलिनोमियल डिग्री इज नॉट डिफाइंड. ठीक है, ये बात को एक बार देख लो फ्रॉम द डेफिनेशन टिल हियर बिफोर आई प्रोसीड फर्दर विद एनी स्टेप्स. बस मुझे बोलो कुछ पूछना है या नहीं.
Sir, till here it is clear.
Till here it is clear. Okay.
Clear.
Okay. Now I'll go to the next part. Now we are going to get a very, very important concept again. What important concept I'm going to get is something called zeros of a polynomial, something called zeros of a polynomial or zero of a polynomial. Zeros is a plural form. Sorry, I made a mistake in the word. It should be Z E. Here it is E. Zeros. Zeros of a polynomial. Zero of a polynomial is better. So I'm writing the definition first. Let fx be any polynomial of a given degree. N. Then a value of x for which f of x is 0 is called a zero of the polynomial. Zero of the polynomial. So it may not be very clear when I have written it like this. So I'll make it more explicit. That is, if x equal to alpha is such that I find the value of f alpha, you give 0. Then x equal to alpha is called a zero of fx. Is called a zero of fx. Please note it down. Now I'll take examples so that I can explain you better. Okay, very nice. So now we'll be taking some examples so that you will get these examples very, very clearly. So what we are going to have here is this. Example, we will take example. Let us consider one polynomial, very small polynomial I would like to consider so that you will understand this very, very clearly. A quadratic polynomial I have considered. Now by this word, value of the polynomial, that is fx equal to 0, what do we mean? That means if I write x equal to 1 and I tell you find f of 1, this is what we call value of fx at x equal to 1. That means value of the polynomial at x equal to 1. And how do we work it out? Very simple. When we write here 1, you try to compare this. You have replaced this x by 1. So morally you are responsible to replace each of these x by 1. And that you do and work out. And whatever values you will get, that is the value of the polynomial. So here what will I get? This is 1, second one is 5, and then third one is 6, and I got 12. I got 12. So when I worked out the value of px at x equal to 1, I concluded with a value 12. Is it equal to 0? Is it equal to 0? No, it is not equal to 0. So if this doesn't come out to be 0, doesn't come out to be 0, x equal to 1 is not a 0 of px. is not a zero of px. This is the stamp we tag for x equal to 1. क्यों? क्योंकि x इक्वल टू 1 बैठाने के बाद हमें जीरो नहीं मिला, पॉलिनोमियल का वैल्यू हमें जीरो नहीं मिला, इसलिए x इक्वल टू 1 इज नॉट ए जीरो ऑफ द पॉलिनोमियल। x इक्वल टू 1 इज नॉट ए जीरो ऑफ द पॉलिनोमियल। ये हो गया हमारा कहानी, ये हो गया हमारा कहानी। ओके, यहां तक समझ में आया?
Yes, sir.
अब कहानी को थोड़ा सा और आगे बढ़ा देंगे हम लोग। इस बार हम इसी पॉलिनोमियल को लेते हैं, लेकिन वैल्यू को लेते हैं सपोज x इक्वल टू -2। मुझे पता है इससे जीरो मिलेगा, इसीलिए मैं लिया। तो तुम f ऑफ -2 निकालो। तो कैसे निकालोगे? -2 स्क्वायर x स्क्वायर के जगह में 5, x के जगह में -2 और +6 तो है ही, तो वर्कआउट करेंगे तो ये +4, ये -10, ये +6, कुल मिला के 0 बन गया। मतलब इस बार हमें एक ऐसा चीज मिल गया कि जो बैठाने के बाद ये -2 को x में रिप्लेस करने के बाद हमें 0 मिल गया है x इक्वल टू। देयरफॉर हम लोग इस बार बहुत ही प्राउडली ये कंक्लूड करेंगे कि x इक्वल टू -2 इज a zero of px, a zero of px, a zero of px. Please see the things. बहुत ही इंपॉर्टेंट है, ये बहुत ही इंपॉर्टेंट है। हो गया? ओके, सो आज का अभी लास्ट एक छोटा सा नोट डिस्कस करेंगे, बाकी डिटेल नेक्स्ट क्लास में होगा। अभी क्वेश्चन ऐसा है कि हाउ मेनी जीरोस, हाउ मेनी जीरोस, एक पॉलिनोमियल का कितना जीरोस है? क्या हमें 50, 100, 100, 150, 1 लाख जीरो मिलेगा? नहीं। ये बहुत इंपॉर्टेंट बात है, दैट द नंबर ऑफ रियल जीरोस, देखो रियल बोल दिया हूं, रियल जीरोस, क्योंकि रियल नंबर के बाद भी हमें दूसरा नंबर मिलेगा, राइट? तो रियल जीरोस कितना होगा? द नंबर ऑफ रियल जीरोस ऑफ ए पॉलिनोमियल, पॉलिनोमियल ऑफ डिग्री, polynomial of degree n is at most बोले तो मैक्सिमम, मैक्सिमम n है, at most n। दैट मीन्स मैं जो अभी पॉलिनोमियल तुमको दे दिया px इक्वल टू x स्क्वायर प्लस 5x प्लस 6, तो इस वाले पॉलिनोमियल का डिग्री कितना है? द डिग्री ऑफ द पॉलिनोमियल इज 2, राइट? डिग्री इज 2। सो अगर इसका रियल जीरोस होगा, अगर रियल जीरोस होगा तो कितना होगा? मैक्सिमम 2 होगा, मैक्सिमम 2। कभी कभी क्या होता है, रियल जीरोस किसी पॉलिनोमियल का नहीं भी हो सकता है। जैसे कल को अगर मैं तुमको एक पॉलिनोमियल दे देता हूं कि px इक्वल टू एक्स स्क्वायर प्लस 1 और तुम इसका रियल जीरोस निकालो, इसका कोई रियल जीरोस नहीं, नो रियल जीरोस, नो रियल जीरोस। बट दिस डजंट मीन दैट इसका जीरो नहीं है, इसका जीरो है, इट हैज टू जीरो, it has two zeros, that is true, right? And unfortunately or fortunately जो भी बोलोगे, these are imaginary, that concept is not with us, so we only stick to the real zeros। सो अगर तुम बोलोगे पॉलिनोमियल का जीरो कितना है, जीरो उतना ही है जितना डिग्री होता है, लेकिन रियल जीरो कितना है, रियल जीरो होता है मैक्सिमम जितना उसका डिग्री है। कभी कभी जीरोस नहीं भी हो सकता, जैसे इसका डिग्री 2 है लेकिन इसका रियल जीरोस नहीं है, लेकिन जीरोस है, दो ही जीरो है, दैट आर इमेजिनरी। बट नाउ प्रेजेंटली यू डू नॉट गो फॉर इमेजिनरी कंसेप्ट, जस्ट सी कि किसी भी पॉलिनोमियल का जो डिग्री है अधिक से अधिक उतना ही उसका जीरो बन सकता है, दैट मनी जीरोस में बी पॉसिबल फॉर दैट रियल जीरोस, रियल जीरोस। क्या ये समझ में आया?
Sir, can you explain one more time?
Which one?
Sir, that one px equal to x square plus 1 example.
Px equal to x square plus 1, you asked me about this. Now you can, if I say that you go on putting the values of x right from 1, 2, 3, maybe root 2, maybe root 3, half, anything, right? Any real number, कोई भी real number अगर put करोगे तो कभी भी जिंदगी में p ऑफ दैट रियल नंबर से, रियल नंबर को मैंने r पकड़ लिया, ये जीरो मिलेगा, ये कभी होगा नहीं। मतलब कोई ऐसा दुनिया में रियल नंबर है ही नहीं जब इस जगह के पुट करोगे और वैल्यू जीरो आएगा, मतलब इसका कोई जीरोस है ही नहीं, नो जीरोस। लेकिन नो जीरोस बोलना गलत होगा, यू शुड प्रिफरेबली से नो रियल जीरोस। मतलब दुनिया में कोई ऐसा रियल नंबर नहीं है जो इस वैल्यू को जीरो बना सके। लेकिन क्या है, जब हमारा रियल नंबर से काम नहीं बनता है, देन वी गो फॉर अनदर टाइप ऑफ नंबर दैट इज कॉल्ड इमेजिनरी नंबर। वो हमारे पास अभी नहीं है, लेकिन जब हम पढ़ेंगे तब हमें पता चल जाएगा कि इस वाले पॉलिनोमियल का भी जीरोस है, लेकिन वो रियल नंबर कैटेगरी में नहीं आता है, वो इमेजिनरी कैटेगरी में आता है। और क्योंकि अभी तक हमें रियल नंबर नहीं, सॉरी, इमेजिनरी नंबर नहीं मिला, तो लमसम में हम यही बोलेंगे कि इस पॉलिनोमियल का रियल जीरोस नहीं है, नंबर वन। नंबर टू, नोट ये बोलता है कि नंबर ऑफ रियल जीरोस इज ऑलवेज मैक्सिमम इक्वल टू द डिग्री ऑफ द पॉलिनोमियल। जैसे उस पॉलिनोमियल का डिग्री दिखाई दे रहा है 2, तो अगर रियल जीरो होता, अगर रियल जीरो होता तो बस दो ही होता, उससे ज्यादा नहीं होता। अब है ही नहीं वो दूसरा बात है, लेकिन होने से मैक्सिमम दो होता है। तुम अगर बोलोगे कि एक क्वाड्रेटिक पॉलिनोमियल का 3 जीरो है, नहीं, गलत है, 3 जीरो होगा ही नहीं। 5 जीरो है, नहीं होगा, गलत है, राइट? मैक्सिमम दो ही होगा। एम आई क्लियर? जैसे तुम्हारे पास दूसरा पॉलिनोमियल पड़ा हुआ है, इस पॉलिनोमियल का दो जीरोस है, दोनों ही रियल जीरो है, तो इसमें हम निकाल सकेंगे। नेक्स्ट डे को हम सीखेंगे कैसे निकालना है, लेकिन इसका दोनों ही रियल जीरोस है, लेकिन इसका एक भी रियल जीरो नहीं है, दोनों ही इमेजिनरी है। दैट्स द थिंग। क्या ये समझ में आया?
Yes, sir.
ओके, सो टुडे आई एम साइनिंग ऑफ। तो नेक्स्ट डे को हम लोग डिटेल में इसका सॉल्यूशन कैसे करेंगे वो पढ़ेंगे, हाउ टू फाइंड द जीरोस ऑफ ए पॉलिनोमियल, विल ट्राई टू सी दोस। आज के लिए बाय बाय करते हैं, राइट? और प्रॉब्लम्स करना, मैं कोई असाइनमेंट दे नहीं रहा हूँ। यस, कुछ पूछोगे?
No, sir. Didn't see that message. That's why.
ओके, हाँ, ठीक है, कोई बात नहीं। विल नॉट वेट नाउ मच टाइम, विल स्टार्ट इट इमीडिएटली। So last day we have started with polynomial. We introduced the polynomials. We have got the concept of zero, but still I'll start a recap from zero only. What is zero of a polynomial? From that we'll be starting with. So first of all, what I'll start is value of a polynomial. Value of a polynomial. And value of a polynomial. let y equal to fx be any polynomial, or you can write only fx be any polynomial. Then the value obtained by putting x equal to a in fx, we get, the value obtained by this in fx, we get f of a. This is called the value of fx at x equal to a. So this is very important. Sometimes we forget, not sometimes, when you go for higher studies in the sense class 11, 12, then only we forget. Right? This is called the value of the polynomial. For example, if we take, say there is a polynomial, a quadratic polynomial I want to consider. Right? This is the polynomial I want to consider. This is the quadratic polynomial. And now if I ask you find the value of the polynomial at x equal to 0, right? So I have to find this. So it is 0 square, 5 times 0 plus 6. So overall you'll be getting this as 6. So if I ask you to find what is f1, it means you have to replace this by 1. So what you get is 1 plus 5 plus 6. This is 12. So 12 is the value of the polynomial at x equal to 1, like this. So now suddenly, if we ask you to find, say, minus 1, so what will be like this? You can get this is 1, this is minus 5 plus 6, it is 2, right? If I ask you to find minus 2, then you put it here, 5 minus 2 plus 6. So this is 4 minus 10 plus 6, giving you 0. So see, quite a few values I have found. This is at f of 0. This is at not f of 0. This is the value at x equal to 0. This is the value at x equal to 1. This is the value at x equal to minus 1. This is the value at x equal to minus 2. Please note it down immediately. And once you note down, please inform me. Okay, so we get these values. Now we have a special interest in a particular value, and that interest will be here, right? That interest we have in this particular value, right? This particular value you see what is the importance or what is the difference of this value with the others. This is the value which are more interested. So here what we observe is that the ultimate value of the polynomial at minus 2 is coming out to be 0. Others are non-zero. These quantities are non-zero quantities. So because it is becoming 0, we have a special interest for that. And in that case, this value, the value for which I have got the value of the function as value of the polynomial as 0, is called 0 of the polynomial. Last day we have defined it, but still I have taken a recap of this. So here I'll be writing again the value of 0, right? So it is 0 of a polynomial. 0 of a polynomial. 0 of a polynomial. So let fx be any polynomial of a given degree, some degrees are there, of a given degree. Then the value x equal to alpha is called a zero of fx if f of alpha is 0. That means once we replace the value of x by this alpha, then we get the value as 0, polynomial's value 0. So in that case, this value of x is known as the 0 on the polynomial. So this is what we got already. We have got it in the last class. So but still I have repeated this so that you can easily understand or you can easily remember this. Right? So if you have finished, you inform me. Okay. So I'll go for the next board and we'll take some questions as example. So question number 1. What do it? Very small questions we'll take first. Find the value of fx equal to twice x cubed minus 13x squared plus 17x. This is not 170. Sorry. This is 17x plus 12 at x equal to minus 3 and x equal to 0. So these are the values they are asking you to find. So that means what they are asking you to find directly f of minus 3. So f of minus 3, directly you put the value here and work it out. This we have put in the place of x and now we'll be working out this. How much? Minus 27, so it will be 54. And then this is 9, 9 3s are 27, 2 and 3 plus 4, 57. And then this is 51 and then 12. So how much will be getting this? There are three negative quantities, one positive. So this will be ended on here. 7, 5, 12. Is it minus 150? Please calculate and let me know. Please calculate and let me know. Make sure what I got is correct or not. I got minus 150. You are also getting minus 150 or not? You check it, please.
Yes, sir, it is minus 150.
Okay, thank you. So next value will be what? Next value will be also like this. So these are small questions just to warm up we are doing. So here to all these terms up to here is 0. So your answer is 12. So from here you can get one idea that always whenever somebody asks you f of 0, it is always the constant term of the polynomial, no matter how big is the polynomial. Always it is the constant term. So this is also one of the, I should not say that this is a result, but this is a small observation which will help you to solve the problems. So this is the next question number 2. I'll write it here. Examine if x equal to 4 by 3 is a 0 of 6x cubed minus 11x squared plus 2x minus 20. So for this you have to examine whether it is a 0 of this or not. So for our convenience we'll name the polynomial as fx. So we'll write here fx is equal to 6x cubed minus 11x squared plus twice x minus 20. Now if I need to check that this is a 0 or not, I have to put this value here. So you go on putting this value. This is cube here, 11 4 by 3 whole square, and then 2 4 by 3 minus 20. So now you have to work on this. This is 4 cube is 64. This is 27, and then this is 11 here. It is 16 by 9, and then it is 8 by 3 minus 20. Anyway, I can cancel a 3 here, so it will be 9. So LCM will be 9. So in that case, it is 128. Then this is 176, and then this is 24, and this is 60. And just to work it out whether it is it is clearly it is non-zero value. Anyway, we'll work it out. It will be 152 minus 236. So anyway, this is non-zero. So if this is non-zero, so x equal to 4 by 3 is not a zero of fx. It is not a zero of fx. So we are done with this. So please note it down. Okay. So I'll go to the next board. Question number 3. Find the zeros of some polynomials are given. You have to find the zeros of that. Twice x plus 5. Name is not given. So what will happen? We'll name the polynomial. Say fx equal to twice x plus 3. We name it. We have named it. Now you see some rough work I am doing here in the sides. By the word 0 of fx, what do we find? We have to find a value alpha so that this makes the value 0. So this value we have to find. So first what we do to find it, we will set this equal to 0, and from here we will find that value. And that is nothing but the value of the alpha. This is the reverse process we'll do. So what we'll write now for 0 will be equating fx equal to 0. Then I'll be getting twice x plus 5 equal to 0. So x will be equal to minus 5 by 2. So x equal to minus 5 by 2 is the required 0. Is the required 0. So this is the way how you need to find this. Right. So any other polynomial, if it is given, say this is number 1, then other polynomial is given. This is 4x minus 3. So similarly, you name it, say it is 4x minus 3. Right. So for zeros, what you will fx will be equal to 0. Fx will be equal to 0, matlab 4 minus 3 is equal to 0. So what is x equal to 3 by 4? Therefore, x equal to 3 by 4 is a 0 of fx. So you are done with this. Right? These are the questions which are there in the NCERT book. So I'm doing similar questions, not exactly this question only. Say one polynomial is there, this you need. So here, so you can write directly for 0, fx equal to 0. So value of fx is 9x plus 2, that is equal to 0. So now, what is the value of x? X will be equal to minus 2 by 9. Therefore, x equal to minus 2 by 9 is a 0 of fx. That's all. So this is the idea how we find the zeros. So this type of questions are there already in the book, right? This kind of questions are already there in the book, in your textbook. So those questions will be homework for you. Right? I'm doing exactly similar type of questions, so there will be no problem. Right? So two more questions I'll be writing. So that questions will be homework for you. I'm writing it here only. Two questions for you as a homework. Please note down these questions. Question number 1. Examine if the indicated value of x is a zero of the polynomial. Right? So there will be a polynomial and there will be indicated value, and you have to examine whether it is a zero or not. This is number one. So for checking zero, you have to check whether the value comes out to be zero or not. There are two values you have to check here. One is x equal to 1, another is x equal to minus 2. So this is what you have to do. Right? Once you finish writing, you will inform me, please. Okay, thank you. So I'll go for the next board. Next board, I'm going to discuss a very, very important part. Very, very important part. It is most important part. So please mark that. What exactly we are going to verify, or what exactly we will understand. You see, I'm talking this about the zero of a polynomial. Suppose you got a polynomial. I'll explain first with the general and then I'll be giving you an example. So this was the general polynomial structure. Okay, this is not zero. Now if I need a zero of this polynomial. If I need a zero of this particular polynomial, right? So what exactly we have to see, you try to see. Every zero, suppose x equal to alpha is a zero, right? If it is a zero, then this alpha, right? Alpha will be of the form p by q. Alpha will be of the form p by q, and this p will be a factor of a naught, and this q will be a factor of an. An is here, right? This is a very important part to remember. Please note it down. It may be happening that ultimately p by q will get reduced and will be getting an integer. It may be also possible. But usually, if we get a 0, so 0 will be of the form p by q, then q will be factor of an and p will be factor of a naught. A naught means the constant term. And this is q is the factor of an, that is coefficient of the highest power. So I'll be taking one example. So in this way, right, in this way, if an is 1, an is 1, it is called a leading coefficient, right? Leading coefficient. Leading coefficient, why? Because the highest powers coefficient is always known as the leading coefficient. It is at the beginning, right? So this leading coefficient, if it is 1, then obviously what is the factor of 1? Only 1 or minus 1. So this q will become 1. So in that case, alpha equal to, that is the 0, better I write the 0 alpha must be a factor of a naught only. Then it will be integer. Did you understand? I'll pick examples. Till now the statement is understood or not that you take.
Yes, sir.
Okay, so this is very important part because this will help us to find the first zero of the polynomial. In fact, all the zeros you can find. So now I'm going to take two different examples, which examples will very definitely explain you the complete fact behind this, right? So here you try to see. Acha, one more thing it is to be there, that these all cases will prevail if this is factoriable, right? Sometimes we do not have factoriable polynomial. In that case this will not happen, right? So now I am going to take one small polynomial so that we can observe it. This is a polynomial, a quadratic polynomial. And now if you observe clearly that the coefficient of the leading term is 1. See, 1. If it is 1, then my 0 should not be of the form p by q. Rather, it will be only of the form p. And this p is factor of constant term. Right? So, at the beginning, just to give a try, what we do, we factorize. We factorize this 6 in all possible. Now just tell what are the factors of 6. So these are the factors of 6. Right? These are the factors of 6. So if this is factoriable, if this we can factorize, then obviously zeros will be out of this only. You will not get any other zeros. So if somebody asks us that you go and trial and error method, so I'll always start from the lowest. But at the same time, you have to use your own ideas. See, here all the terms are positive. So now there is no question that if you put positive value for x, it will be ever 0. So ये तुम्हारा common sense है. It is your common sense. So whenever I have to pick numbers from here for trial and error method, obviously I should pick the negative numbers, right? So let me test with -1 first. I know -1 is not going to give you because this is a polynomial just before few minutes I have taken. So this is going to give you answer 2. So it is not equal to 0 means it is not a 0 of the polynomial. -2 you check what you'll get. You will be getting this satisfied by this. Similarly, if you test -3, that is also give you the answer. So in fact here you just try to see, we are very lucky here that as this is quadratic polynomial, it has two zeros and we got both the zeros. X equal to -2 and x equal to -2. Got it? So we can find the zeros here like this also. If you have anything to ask, you can ask me. I'll go for the another explanation also once you approve.
So I have understood it.
Okay. So now we'll be considering another polynomial where the first leading term is not 0. Say twice x square plus x mm, minus 3. Twice x square plus x minus 3. Right? So this is a polynomial. Now this is a quadratic polynomial, so we can have two zeros. So at the beginning, if we need to make a try that what value of x I should put to test. First of all, what I'll see, factors of this and this will see. Factors of 3 will be plus or minus 1, plus or minus 2, not 2, 3. These are. And factors of 2 will be plus or minus 1 and plus or minus 2. Now try to remember this. Factors of 2 will come in the denominator, factors of 3 will be come in the numerator, will be coming in the numerator. So in that way, all possible you make, just you see how will be constructing. Suppose this 1 plus 1 I have taken, plus 1 I have taken. So I can pair with this 1 with 1, this plus 1 with minus 1, right? And then 1 with 2, 1 with minus 2. These are the four possible. So this is equal to 1, right? And this is equal to -1. Others are okay, half and minus half, right? And then I'll now pair this 3 by 1 it can be, 3 by -1 it can be, 3 by 2 it can be, 3 by -2 it can be. Am I clear? Now out of that, this will be equal to 3, then minus 3. These will remain fractions, right? We first took both the positive values. Now you see the negative values, if you now take, it might match with the previous sum values. Just say here in the numerator I have taken only plus 1. Now if I take minus 1 here in the numerator, minus 1, here I have to take both the value. Minus 1 by 1 will be giving you minus 1. So already counted. So I need not count it again. Minus 1 by 1, minus 1 I can consider here already counted. I need not count it. Okay. Minus 1 by 2 here already counted. It is here. Then minus 1 by minus 2 also you do. It is already counted. That means I have counted already values for minus 1. Similarly, if you take minus 3 here, again these values are already counted. Are you getting what I am trying to say? I am actually trying to find all possible pairs of P by Q. See, this is not the method. This is an observation. Right? This is to be known. This is not the method to find the zeros. Find the zeros, there is other method. Only thing is that this is the idea how we try to see the problem. So do not get like embarrassed that if so many trial and error we have to do, how much time will do. No, this is not the method. So just try to understand the backbone. Have you understood the process?
Yes, sir.
Okay. So now you have these 8 possibilities. Out of these 8 possibilities, 100% sure some of them, some 2 of them will satisfy that. Now you have to go for trial and error, right? So trial and error, you try to see. This time you cannot say that your negative will work only. Positive might also work, right? Because it is a mixture of positive and negative terms. So you never know, but you always try to start with the smaller ones so that it will be easy for you. Smaller ones and then fraction free. That is minus 1 1 and 3 minus 3 you test. So let me test with 1 only. 2 into 1 square, 1 minus 3. What will it give? 2 plus 1 minus 3. Then this is 0. We are lucky. 1 is a 0. X equal to 1 is a 0. 1 0 we got. One more is needed. One more is needed. Right? One more is needed. Now you try to see one more thing. Very important thing. Very, very important thing to be understood. The other one, the other zeros will be a fraction now. Why fraction? Question is that. That is to be understood from here. These two numbers, when you say, do they have any factor common other than plus or minus 1? No. No other factors are there, right? So if only one factor, that is 1 is common, then one root may be integer, other root has to be definitely in the form of PY, of fraction, right? So had it been 4, this 3, you would have considered another integral root. So here, this should definitely give you a kick, means indication that either you have to test this or you have to test this. So now absolutely I don't know which I have to test. So you have to go on testing from the smaller values. Say half I'll test. Say half. So if you test half, how much it is? 2 into half square plus half minus 3. Then what will happen? It is 1 by 4. So it will become half. It will become half 3. So ultimately 1 minus 3 minus 2. So it is not a 0. Right? Similarly, from here only you can anticipate minus half is not the possible case. So you took 3 by 2. Right? That is trial and error method, and trial and error method does not have any more logic. It is the like intuition what you have. So probably this will give the answer. It is 9 by 2, and then this is 3 by 2 minus 3. So 12, this is 3 by 2. 6 minus 3 will give you 3 only. So this time this is also not 0, right? So that means ultimately you will be getting this as the 0, this as the 0, right? You please check it and let me know. I'm not going to check this. I'm waiting. Please check f of minus 3 by 2 is a 0 or not. It should be the 0 because already 3 by 2 is not a 0.
Sir, it will give 0.
Okay, it will give 0 means minus 3, x equal to minus 3 by 2 is a 0. So these two are very important. Please remember these things. These things are very important. Oh, sorry, it will be covering. These things are very important. Right? You always try to remember this. Right? So now I'll be moving to the next board. Just going for the another problem. So we are going to start with another problem. This is question. I don't know what question number I was doing. So anyway, that is not a problem. It is an important question. Find the value of a if find the value of a if x equal to 2 is a 0 of fx equal to 2x square minus 3x plus 7. If it is a 0 of this function, this value or this polynomial, then you have to find what is the uh, value of a. So now you see it is given this time. Given that x equal to 2 is a 0 of fx. So if it is a 0, already we came to know that always 0 satisfies the equation. Satisfies the equation means if I find the value of the polynomial, this should come out as 0. So this is the starting point. If you are clear about that, then the rest of the part is having no problem at all. From here you can easily find what is the value of a. So how much will be getting? A as minus 2%. So a value of a will be minus 2%. Check this. So this way you can find. Right? Have you understood?
Yes, sir.
Okay. So after this, you will be having questions from the book. Those questions are very much similar to what question I teach so far. So those questions please do. Right? Anyway, now I'll be discussing even some other questions. One question I'll give you that you do as a homework. This is find zeros of. This is to be done by the trial and error method, right? For practice, I am giving you. Please try to do that. This is twice x cube plus x square and then 7x minus 6. This is one. Another one will be giving you a quadratic equation. Right, say x square minus twice x square minus twice x, and then minus 24. 2 to the power 4 near 24. So this two you do by trial and error method. This will be a little easier because coefficient of x square is 1. This will be a little longer. But still you do it. Right? I'll go for next board. Have I written the question? Okay. So I'll go for the next board. Next board, we are going to get very important theorem. There is a very important theorem called remainder theorem. Remainder theorem. It is called remainder theorem. So I'll write the statement first. Let y equal to fx be any polynomial of certain degree. कुछ एक डिग्री का polynomial है, right? If fx is divided by x minus a, then the remainder is given by f of a. Please see, my handwriting is not very clear. Let's try to see it. If y equal to fx be any polynomial of a certain degree, and if fx is divided by x minus a, then the remainder is given by f of whatever remainder is there, that is worked out by f of a. So first I'll explain you what exactly is the thing. So suppose you have divided this polynomial fx by x minus a. So you will get certain qx and then you will be getting certain remainder. So this remainder is f of a. They have said like this. We have to show that. This only you have to show. I'll show you a quick proof of this also. But before that, please write down statement. So we'll be starting with the proof, right? So you see, I'll not write maximum statement. I'll write the minimal statement. So if fx is divided, this is a dividend. So dividend will be equal to always what? Divisor into quotient plus remainder, right? Division into quotient plus remainder. Now you put a in all the places, right? That means f of a we want to find. So you'll be getting like this. Now this is f of a. This whole thing will be 0. And this is what left out is the remainder. Right? This is what left out is the remainder. So your f of a will be equal to 0. R. This is the remainder. What you get is the required result. So this is the proof. This is the Am I clear? Okay. So this theorem is very important. Now with the help of this theorem, we can solve many questions. So one small question I wanted to say, question number 1 of this. Find the remainder. Find the remainder if f of x squared, say this is twice x plus 3, is divided by x minus 1. Right? This is divided by x minus 1. Remainder theorem से ही करना है. तो फिर and this is comparable to what? X. This is minus is here. This is with a. So what is the value here? A equal to 1. That means x equal to 1 you have to replace. Or rather, how you can do is whatever is the quantity equal to 0 and then get the value of x. This is the idea. So this is the value you have to replace now. So directly you write, do not write remainder theorem now. Simply you first find f of minus 1 equal to what? you got this as 2. So last may write by remainder theorem. Remainder theorem required remainder when fx is divided by x minus 1 is 2. This is the idea how we do it. Am I clear to you? So you just I'm taking one bigger question now. Say f of x equal to x cube plus 2x square minus 3x plus 12. And then this particular one I want to divide by x plus 1. What is the remainder? What is the remainder? This is the divisor. Zx. By zx I want to divide. So what is the remainder? So from here you can see put what is the value? X equal to minus 1. You need not show this calculation outside it will be. Only directly you will do f of minus 1 and work out whether it is sorry and work out what value you get. That is the required remainder. This is minus 1. This is plus 2. This is plus 2. 12. So 12 plus 3 15. 15 plus 2 17. Minus 1 16. So therefore by remainder theorem. At last conclusion, you do not forget to write like this, that remainder theorem has been used, right? Remainder is 16. So you got this. Yes. If you have understood, okay, thank you. Am I moving faster? You are able to
No,
follow?
sir.
It's
Yes,
okay?
sir.
Okay.
Yes, sir.
So now next we are going to get a very important another theorem, that is factor theorem. Factor theorem. Actually, factor theorem can be obtained from the remainder theorem only. You see how we can obtain. If I am dividing this by gx and here we get qx and then we get here the remainder. So at last we say that the remainder is f of a. Remainder is f of a. Right? If you put a in place of x here, then this is the remainder. Acha. When remainder will be 0, what do you say? Gx is a factor of fx. So that's the actual implication, that if remainder is 0, then divisor is a factor, right? So remainder 0 means f of a must be 0. So our statement is going like this. Let fx be any polynomial, right? Then number 1, x minus a is a factor of fx if f of a equal to 0, and conversely f of a equal to 0 if x minus a is a factor of fx. This is the vice versa condition you have to remember. Vice versa condition, right? This is a vice versa condition, मतलब उल्टा पुल्टा conditions. अगर रिमाइंडर होगा, सॉरी फैक्टर होगा, तो f of a must be 0 होना है, और f of a 0 होने से फैक्टर होगा. So now we can get a test, a question. So I can write, examine if x minus 3 is a factor of x square minus 3x plus 10. This is the name of the polynomial. Now we have to check whether it is factor or not. Right. So what I'll do directly, we'll be putting 3, right? Because if you equal this to 0, 3 will get. So you put instead of x the value 3 and then go on working out. So you get this is 10 and this is not 0. Therefore, x minus 3 is not a factor of fx. Is not a factor of fx. Had it been 0, you would have said very comfortably that it is a factor of fx. Just take 5 to 10 seconds and go through it, and let me tell you if you have any queries, questions. Okay, so I'll go to the next board for another question. Next question, right? So you see, find the value of a. Find the value of a if fx equal to 2 2x cube minus a, sorry, plus ax square plus 3x minus 5 and gx equal to x cube plus x square minus 4x plus a, leave equal remainder, or rather same remainder, on division by x minus 2. So if these are the cases where if you divide both the polynomials, this as well as this, by x minus 2, remainder same, in that case you have to find what is the value of this. So solution. So you can easily write remainder when fx is divided by x minus 2 is equal to, better you write here according to question, remainder when fx is divided by 2 equal to remainder when gx is divided by x minus 2. Now what is the remainder? It will be f of 2, and what is the remainder here? It will be g of 2. Now f of 2, you find this is 2 into 2 cube plus a into 2 square, then 3 into 2 minus 5, and right side it will be 2 square, sorry, 2 cube, and then 2 square, and then 4 into 2, and then plus a. Now this is going to be 16, this is 4a, then this is 6 minus 5, and this is 8, 4, 8 plus a. Now here you see if anything is getting cut, you cancel it, and then you try to work on. You said this 8 and this 8 will be cut here, this side, so this side to nothing is cut. Now this is 4a, this is a. If you take uh, this a to the left side, you'll be getting this is 3a, and the rest you take to the right side. 4 is already here, then 16, and this if you add 20. Acha, first you subtract this two, that will be better. 1 will be here, will be 17, that side minus 17, so it will be minus 13. So value of a will be equal to minus 13 by 3. Please check the calculation once. So value of a will be minus 13 by 3. I think I did not commit any mistake here so far. But still, once you please check the values calculation को देखो एक बार correct है या नहीं is it okay
Yes, sir.
okay now I'll be taking just 2-3 more minutes actually division is there but division I'll not explain you or division about the factorization that I'll do next day so now just I'll be leaving you with algebraic identities because these identities are needed for factorization so by the next day when you join this should be very clear out of this already many things you got in class e7 only right so just you see I think you need not note down all this just see this can you recall this you got already
Yeah.
so this whatever you did not get that you write this cube you might have not got so you write this is one of the expression other is a cube plus b cube 3ab a plus b and then next a minus b whole cube is giving you a cube minus 3a square b 3ab square minus b cube and then this is a cube minus b cube will be minus 3ab a minus b here right and then a plus b plus c whole square will be equal to a square plus b square plus c square plus twice ab plus twice bc plus twice ca these are one very important and then one more extra I'm writing that is not extra actually it is from them only but this is extra I'm writing because this is very important this is a cube one that can be written as a plus b plus c
A
now
square
here
plus b
minus
square.
3abc is there a plus b plus c minus 3abc equal to a plus b plus c whole cube minus 3abc equal to a plus b plus c whole into a square b square c square minus ab minus bc minus ca. So these are the identities which you have to remember. One more is there which you got in class 8 only that actually in the beginning only it was there. I forgot to write. It is x square plus a plus b whole x ab. So this is all for today. Please write it and let me know if you are finished. I'll be disconnecting. Okay. So Ritika, today I'll finish it and then till next day you try to do some of the exercises. Very definitely I'm sure you'll be able to do some of the exercises 2.1 and 2.2 at least you try. Right? You try to finish those. 2.1 and 2.22 you can do very easily. Right? So next day we'll start with 2.3 and problem related to